The first thing was to create the map. The map we designed was a 19 by 19 map. The map has an avenue to the center of each block on the grid. A thing to note here is that since the map appears vertically flipped, after applying the path planning algorithms, we had to first design our map, vertically flip it, and then store it in MATLAB. Later, we had to apply our path planning algorithms, and then our map appeared correctly. We then drew out the map using a robot, and this was the final output. In this project, we used two path planning algorithms. The first one is a D-star algorithm, which is an incremental search algorithm that selects a path between a start and a goal location by considering the minimum cost on the map. Additionally, we use the Probabilistic Road Map algorithm that selects a path between a start and goal location by randomly placing various points throughout the map, avoiding the obstacles, and then finding the shortest route by connecting the points from the start till the goal. Together with these path planning algorithms, we tested different interpolation methods to obtain smoother curves for the final trajectory. We used ctraj that fits linear splines throughout the data with a trapezoidal velocity profile. Additionally, we used lspb that also has a trapezoidal velocity profile. Finally, we used tpoly that generates a scalar polynomial trajectory that varies smoothly using a quintic fifth-order polynomial. Here we show an example of how to move our robot from one center to another center using a specific algorithm. In this case, we want to move our robot from the center of block 3 to the center of block 5 using the D-star algorithm and no interpolation. This was the output.
Using no interpolation with D-star, the path is drawn simply by connecting the point and the trajectory is drawn by the robot with constant velocity. In this case, it took our robot 7.79 seconds to move from position 1 to position 9. ctraj connects two points using a straight line and draws them using a trapezoidal velocity profile. So using it with D-star, it took our robot 49.84 seconds to move from position 1 to position 9. lspb uses a trapezoidal velocity profile as ctraj, but the only difference between them is that it does not connect two points using a straight line but more smoother curves. So it takes about 50.97 seconds to move from position 1 to position 9. tpoly uses bell curve type velocity profile, which is more smoother compared to lspb, but the drawback is that it takes more time. So in our case, it took 52.61 seconds to reach from position 1 to position 9. PRM takes 10.05 seconds to move from position 1 to position 9, since the path is not always as short as D-star. ctraj takes 59.12 seconds to move from position 1 to position 9 because of the path selected by PRM. lspb uses trapezoidal velocity profile, which means that velocity will increase at the start point, then it will remain constant, and ultimately it will decrease at the end point. Thus results in 1 minute and 10.91 seconds for trajectory generation. Similarly, tpoly takes 1 minute and 24.27 seconds because of more smoother velocity curve and longer path.
To conclude, we would like to note that the path generated by PRM is sometimes longer than the D-star algorithm because the path generated by PRM may not always be the shortest, as it depends on the random location of the points on the map. We can note that all the trajectories with and without interpolations with the PRM take more time than with the D-star algorithm. Thank you for watching.